Hello, my name is Raquel Silva. I am a master student in the postgraduate program in Photonics Medicine at Universidade 9 de Julho. My advisor is Professor Raquel Agnelli Mesquita Ferrari. The title of the student is Impact of Vascular Photobiomodulation on Collagen Deposition and Distribution in an experimental model of acute muscle injury. The connective tissue present in muscle tissues plays a crucial role in muscle regeneration, providing structural support to the endomysial, perimysium, and the epimysium layers. These layers are also vital for the nutrition, oxygenation for muscle fibers, and stability required for movement and contraction. Additionally, the significance extends to the modulation of the inflammatory process during cellular proliferation and the formation of the new muscle tissue. Collagen is a structural protein found in various areas of the human body, with several types of collagen. Type 1 collagen is the most abundant in skeletal muscle with strength and stability functions of muscle tissues and transmissions of force to the bone. Along with type 3 that has structural functions of muscle fiber force transmissions. 4 and 6 collagen support contraction and the relaxations muscle. Muscle injury carries absent consequences, especially for high performance athletes who rely on optimal muscle functions. Following injury, limitations in infection and muscle pain are if the post-injury inflammatory process is prolonged, excessive deposition of collagen and fibronectin can result in tissue fibrosis, which negatively impacts muscle recovery. Ideally, organization remodeling of connective tissue is necessary to ensure the preservation of muscle functions. Photobiomodulation has shown promise in tissues remodulation and regeneration, particularly in reduction inflammation and improved muscle tissue health. The application of photobiomodulation before injury has shown positive effect on collagen organization and deposition. Vascular photobiomodulation is a non-invasive technique for systemic lighting application, making it a potential method for primary photobiomodulation in muscular tissue. This is especially relevant due to the challenges in predicting the site of a muscle injury and the typically extensive nature of such injury, making its application more feasible. There is a shortage of study in vascular photobiomodulation and the collagen deposition process in the literature, mainly with preventive application. The objective of this study is investigating the impact of muscular photobiomodulation administered prior to inducing acute muscle injury in rats on the overall collagen deposition, which the healing muscle tissue following prior injury. The research was approved by the Ethics Committee for the use of 15 rats, which were randomly divided in 3 groups: control, injury, and pre-injury vascular photobiomodulation. The animals underwent a collagen procedure using nitrogen above had labs targeting the anterior tibial muscle. The pre-irradiation group received vascular photobiomodulation 24 hours before the injury. Euthanasia was performed 2 days after the correlation. Muscle samples were collected from the right muscle of both animals. This muscle sample was a histological process and studied what precursors read to quantify the total collagen are using imaging software. The vascular radiation was performed in direct contact with the tissue under the caudal artery of the rats. They received pre-injury vascular irradiation. The dosimetric parameters were described in the table. In the analysis of the photos of histological sections studied with precursors rats, which allows to analyze the distribution of collagen, we can observe an increase in collagen in the injured groups compared to the control and pre-injury vascular photobiomodulation groups. In the quantitative analysis, we observed a significant increase in collagen content in the injured groups compared to the control groups, and the pre-injury vascular photobiomodulation groups, which was similar to the control group. So we can conclude that vascular photobiomodulation effectively modulates collagen deposition in the skeletal muscle tissue during the repair process following acute injury. However, additional students are required to delve further into the mechanisms of vascular photobiomodulation, especially concerning the relation to optimal dosimetric parameters. This is my references. I thank you everyone.